Right, hello there. In this video, I'm going to introduce you to rates of reaction. So we'll have a look at why particles react together, and we'll have a look at the collision theory. This video is primarily aimed at GCSE students. However, you might be doing this at Key Stage 3, or you might be an A-level chemistry student that just needs a little bit of a reminder. Now, this is the first video in a series of 7. They're all going to be short, and we'll have a look at rates of reaction and the factors that affect the rate of a chemical reaction, and then we'll end up with how to monitor the rate of a chemical reaction, and we'll have a look at rates and graphs finally. So I'll have a look at the collision theory with you. We'll have a look at why the vast majority of collisions don't lead to a chemical reaction. We'll have a look at what activation energy is, and we'll have a look at what we can do to change the rate of a chemical reaction. So quite simply, to react, particles have got to collide. No collision, no reaction. And the vast majority of collisions don't lead to a chemical reaction because quite simply the particles just bounce off one another and they stay as reactants. So this is an example of a collision that hasn't been successful. The two atoms of two different elements have collided together, they've bounced off one another, and they've stayed as the same elements. There's been no reaction at all, no change has happened. But some collisions, where the particles, once again two atoms of two different elements, collide together, and this time we have had a successful collision because what's happened is a bond's formed between the two atoms of different elements, and we've got a new product, we've got a compound here. So two atoms of different elements joined by a chemical bond. Now, why do a lot of collisions not lead to a chemical reaction? Well, firstly, the particles might not be in the correct orientation, so they might not be colliding in the right way round. But more importantly, is the collisions don't have enough energy. Trying to be really specific with this, the collisions have got energy lower than the activation energy. Now, it's really important we know and understand what activation energy actually is. So it's the minimum amount of energy required by colliding particles to react. If the energy is below the activation energy, there will not be a reaction. If the energy of the collision is above the activation energy, there could be a chemical reaction. Now, you may see activation energy given the symbol EA, and that's like this, so a capital E and a little subscript A like that. Now, what can we do to alter the rate of a chemical reaction? Well, we could increase the concentration of a solution, or we could increase the pressure of a gas. We could increase the surface area of a solid, so we could grind it into a powder. We could increase the temperature, or we could add a catalyst. And I'm going to cover all of these with you in the following videos. Okay, so that's an introduction to rates of reaction, hopefully made simple for you. Thanks for watching.